Good day, students. In this video, I will discuss an introduction to analytic geometry and also discuss one of the basic concepts in analytic geometry, which is the Cartesian coordinate plane. So let's start. So what is analytic geometry? Analytic geometry, which is also called coordinate geometry, is a mathematical subject in which algebraic symbolism and methods are used to represent and solve problems in geometry. Now, how is it different from the geometry that we had before? Now, before, most of the time, we made use of straight edge or a ruler and a compass as our basic tool in solving geometric problems. Now, here in analytic geometry, it will require us the use of algebra as our main tool in solving geometric problems. Aside from that, we also call it coordinate geometry because most of the time we'll make use of the Cartesian coordinate plane to solve problems. So we will be given points which can be plotted in a Cartesian plane to describe figures and shape which we will deal in certain problems. Moreover, it is also concerned with algebraic solution of algebraic problems and geometric interpretation of algebraic equations. So therefore, it is necessary for us to recall the different algebraic concepts that we have learned before in AT Math 1. And also, we will also try to interpret various equations and try to define them, whether they are lines, curves, ellipse, parabola, or a hyperbola. Now let us continue. Analytic geometry or coordinate geometry was introduced by René Descartes, a French mathematician in 1637. Now I think most of us know who is René Descartes. He is the famous mathematician behind the invention of the Cartesian coordinate plane. So he invented the Cartesian coordinate plane in 1637, and from that point, the study of analytic geometry started to develop. So basically, analytic geometry is a combined study of Euclidean geometry with algebra. So when you say Euclidean geometry, it is study of shapes through the use of axioms and theorems. So in this lesson or in this subject, we will combine Euclidean geometry with algebra. Now, let us get to know more first René Descartes. So René Descartes is a French mathematician and a philosopher. So aside from being a great mathematician, he also graduated law at the age 20, and he also became a military engineer. So most of his time when he was alive was devoted on the study of human psychology, philosophy, leisures, natures, and also mathematics. And then until it came 1637 where he invented the Cartesian coordinate plane. So what is Cartesian plane? So the Cartesian plane is a plane with a rectangular coordinate system that associates each point in the plane with a pair of numbers. So basically, it is just putting address on every point on a plane. Now this Cartesian coordinate plane works well with many simple situations in real life. Say for example, you are renovating your room or you are reconstructing the floor plan of your room. So with that, you can start with planning where to place the different furnitures in your room. And you can start by drawing a two-dimensional grid by representing the room and use an appropriate unit of measurement on each side. So with that, you can estimate properly kung ano yung mga tama na furniture and which furnitures can fit in your room. Now, it's not only in that scenario where we can see the application of the Cartesian coordinate plane. Now, it can also be seen in maps. Now, if you're someone like me who uses Google Maps most of the time, now remember that you can make use of the geographic coordinates provided in the Google Map to describe the exact location of a certain place. Now, that is just one or a few of the applications of the Cartesian coordinate plane in real life. Now in math, Cartesian plane is a way of uniquely naming points or ordered pairs on an xy plane. So it is unique because there are no two points on the Cartesian plane that have the same address or ordered pair. Now, how do we name a point on the Cartesian plane? So we make use of two numbers, x and y. Now, x here basically tells you the location of the point based on the horizontal number line. And the y value here refers to the location of the point on the vertical number line. Now here, let's get to know the parts of our Cartesian plane. So let two number lines intersect each other at a right angle at point O, which is what we call the point of origin. So at the point of origin, our ordered pair is 0, 0. So here in the illustration, you can see that the horizontal number line is what we refer as the x-axis, and the vertical number line is what we refer as the y-axis. Now looking at our illustration, we can see that our Cartesian plane is divided into 4 regions. And these regions are what we refer as the quadrants. Okay. So we have here 4 quadrants. The first one is named as quadrant 1. The second one is quadrant 2. And we have here the quadrant 3. And lastly, we have the quadrant 4. Now, on each quadrant, the points that we can find specifically on each quadrant share the same characteristics. So say for example, for the points in quadrant 1, all points on this quadrant are both positive in x and y value. Now, moving on to the second quadrant, all the points will have a negative x value and positive y value. For the third quadrant, all the points will have negative x and negative y value. And lastly, for the fourth quadrant, all the points will have a positive value in x and a negative value in y. Now let us consider a point P on the plane, and let's say that this point 2, 3 is that point P. The point P represents its location, and an ordered pair of real numbers xy indicates its coordinates or address on the plane. Now, remember that when we name points on the Cartesian plane, we make use of capital letters. So say for example, in this one, so you can name this as point P, okay? To name the rest, you can make use of capital A, capital B, capital C, or any capital letters. So you may also add the ordered pair beside it, but it's optional. So you may or may not write the ordered pair beside the name of the point. Now, when it comes to ordered pairs, the x-coordinate of P is what we call the abscissa, and the y-ordinate or the y-coordinate is what we call the ordinate. So for your activity, which will be uploaded on the Google Classroom, all you have to do is determine the coordinates of each point and its location on the Cartesian plane. So you have here on the illustration points A to H. So for coordinates, you have to give its ordered pair, and for its location, you have to tell where it lies in the Cartesian plane. And that's it for this video, and the next topic will be distance formula. If you have questions regarding this topic, feel free to message me on Google Hangouts or email me through my Gmail account. And that's it. See you online.